Hello everyone and welcome back. So in order for us to be able to create these sparks and sim particles that matches the movement of the smoke sim or fire sim, whatever we're creating in DOPS, we need to cache out the velocity field. After that, we create a secondary sim and we use that velocity field to advect the particles. Now, to cache this velocity field is going to take a lot of disk space. And there is no workaround. There is no way around that. If you want to have the particles match the fluid motion, you have to have the velocity field cached and use that. Now the drawback is that the particle sim, if it's going to read, let's say 500 megabytes per frame of velocity cache from disk every frame, it's going to be slow to sim. Even if the particle sim is super fast, the IO, the disk speed is going to cause this to slow down quite a bit. And when I started looking into this, I realized that I'm going to have a lot of fire. I'm going to have, a lot of sparks, and whether it's the crack shot, which has, multiple individual sims per crack, and it's going to be huge disk space, which I did in the first use case, just to focus on getting the sparks motion correctly. And what do we need to get, or the main feature that we need with these sparks is that they have to have two properties or three main properties. They need to move along with fire, and they need to give us this stretched look as they get faster and faster. So we need to get that streaky look in there going. So we have to make sure that we are able to get that look. The other thing, these sparks they are not circles. They are not they're not going to look the same from every angle, okay? Which means they can rotate. And if you have a disk that rotates, you see it one frame, and then the next frame you see quarter of it, like the moon, and then you don't see anything because it's aligned exactly with the camera. So we need that sparkling feature. And then the other main criteria for the sparks is when they get close to dying, they become very, very turbulent. Okay, so the initial phase, you see them slowly moving with the fire, and then as they get closer to dying, they either they do the you see them going in a flow and then dissipating quickly, and they drift away from the smoke at that phase because they been taken care of by a different force, or they lose weight and they become so light that they can move that way. So that's a very important behavior, and you can see it here. You can see, for example, this part, when it dies off, they are swirling and they're getting very, very turbulent. And that's also going to help with the streaky motion, because if they get faster as they die, we're going to get that nice streak placed nicely. And then I have the rotation. So you'll see the sparks, they are actually spinning in an interesting way. So you see them one frame, and then the next frame they rotate, so they look smaller. And then we have size randomization. So this is the main features that we need to get implemented in stops or in pops. Cool. The next thing is we need to advect them with the velocity, and that's very simple to do. Now, with that said, caching the velocity is very, very heavy, and reading it is very, very heavy. So my next solution, or my next feature also that I wanted to add, is to have, because it's a large spark system or a large scale fire, I wanted to see the sparks behaving in their own way. Along with moving nicely with the fire flow, I want them to create some kind of turbulence. So instead of just following everything, I want this, for example, to create a small tornado. This one to create a small tornado, and this one too. And that's something that we have to implement. And you can see it here. So you can see this large area. We're getting these streaks, these lines forming, and then everything else is just following the fire. Now this segment here, all the other three sims, I made a mistake not to include all the data necessary for them to get simmed like this. So I missed to plug in one thing, but I ended up using this because I've run out of time. but they should all look like this. Now, apart from that, we still get all the features that we need. It's following the fire and it's moving in an interesting way. It's getting turbulent. We're getting the streaks and everything. And the sparks are working nicely from all the angles. So this is far away to mid, and then I'm gonna read in another one. This one is empty. So this is a close-up fire. And it's a bit slow to read, but you can see we're getting these nice streaks. We're getting this nice turbulent. And this is the best section to look at for reference. And obviously we have to have the collision to make sure that they are not going through the geometry. So we have to have that. And it's working. I lowered the settings. You can see a little bit of jittering, but we will look at ways to fix that and improve it in comp. Okay, so let's start in Houdini and create a basic setup to get the flow going, to fully understand this, and then I'm gonna go back and explain what the setup from week 6 is about, the one I asked you guys to place inside the DOBs called PTS, that solver, and how my idea is going to work. So let's get started. Thank you guys for watching, and see you in a bit.